Today I'd like to speak to you about how to do a properly performed gram stain. So the gram stain is one of the most important differential stains that you could do in microbiology. It's called a differential stain because it differentiates between the two large classes of bacteria, the gram negatives and the gram positives. So let's get started. What I've got here is a microscope slide. Notice I took a grease pencil and I marked a perimeter, a large circle around the center of the field of view of the slide, and then on the frosted edge I put an identifier so that I'd know whose slide this belongs to. I do this for two reasons. First of all, the grease pencil line will serve as somewhat of a dam, so when you wash your gram stain slide, you will tend not to wash all the bacteria away. The other thing it could serve as a point of view when you're looking in the microscope and you come to the edge or the perimeter of your grease pencil slide, you'll know there's nothing past that way, go back the other way. So now that you have your slide marked, you're ready to inoculate it. The first thing I want to do is take my inoculating loop. I'm going to incinerate it for about 10 to 15 seconds to make sure that there's no contaminants on my loop. The next thing I'm going to do is pick up a plate. Notice that I'm working with a pure culture here. As you can see, I have individualized colonies on this side, so I'm going to drag a couple of those small colonies from that pure culture side. Then I'm going to take those to my microscope slide. Starting in the center and moving in concentric circles, I'm going to get larger and larger with my perimeter. Now keep in mind, guys, thicker is not better in a gram stain slide. You want as thin a sample as possible. Once you have it to this point, you're ready to re-sterilize your loop. So now the next step in this process is called heat fixation. In the heat fixation process, you're going to set your slide on top of a warming tray for several minutes or until it's dry. This process allows the bacteria to be affixed to the glass so they're not washing away so easily. Now, once I have my bacteria heat fixed to my slide, I'm ready to begin gram staining. The first step in the gram stain process is crystal violet. So I'm going to apply crystal violet stain directly to my slide. Just a few drops will do. Notice I'm going to stay inside of my wax pencil perimeter. I'm going to allow that to sit on the slide for approximately 1 minute. Now, at the end of 1 minute, I will quickly pick up my slide at a 45-degree angle and rinse off the crystal violet. The next step in the gram stain process is to add Gram's iodine. Gram's iodine will act as a mordant and cause the crystal violet to make a larger molecule, which will then get stuck inside the peptidoglycan layer of the cell wall. This time I'm going to use this for about 2 minutes. At the end of 2 minutes again, I will rinse my slide and I'm ready for the most critical step of the gram stain procedure, the decolorizer. The decolorization step is the point in which you will determine between gram positive and gram negative bacteria. The best way to do this is to hold your slide at a 45-degree angle, apply several drops of decolorizer for no more than 2 to 3 seconds, and then immediately rinse the slide with your DI water. Any longer than that and you will have over decolorized your slide. The last step in the gram stain process is to add safranin, which is called the counter stain. This is the point in which the gram negative bacteria will pick up the counter stain and become red or pink under the microscope. Again, this will be done for 1 minute. At the end of 1 minute, you would rinse your slide, then place the slide inside a clean set of sheets of bilbulous paper. Gently tamp down on the slide until it's dry, and you're ready to view your gram stain slide under the microscope. Let's see what it looks like.